This is Algebra 1, Lesson 6-1, Systems of Linear Equations, Graphing. All right, so I want to state that while I do teach a lot of shortcuts like how to do slope-intercept form or how to do standard form, really everything boils down to, can you just use a table? If you can use a table, you can single-handedly solve every single graphing type problem that I throw at you in all of math. This applies to Algebra 1, it applies to a little bit in geometry, a ton in Algebra 2 and pre-calculus. If you can just use a table, it will generally solve all of your problems. So let's review how to use this table. So let's pretend I did not know how to graph slope-intercept form, and I just had this. And I said, okay, I have a table of x and y values, and I want to somehow convert this equation into a graph over here using this intermediate step. So what do? I plug random numbers over here. Like, I don't know, let's plug in 0. Let's see what happens. If I plug in 0, that means x is now 0. This x right here is now 0. This now says, and I can rewrite it, this now says not 2 times x, but 2 times 0 plus 3. And I know that if I multiply 2 times 0, that's 0, and 0 plus 3 is 3, so the output here is actually 3. And what I've done now, I have an x and a y coordinate. You always go x, then y, left and right, then up and down. 0, 3, which means I'm going to go nowhere left or right, and I go up 1, 2, 3, and I have a point on my graph. And I can do this again. Let's plug in another random number. Let's plug in 1 and see what happens. If I plug in 1, again, this is the x value. Here is 1, so I'm going to rewrite this, but instead of a x here, I'm writing a 1. This now says 2 times 1 plus 3. Okay, 2 times 1 is 2. 2 plus 3 is 5. So I can say, okay, if I plug in 1, the height is 5. So if I go over here to 1 on the x-coordinate, 1 has a height up here of 5. And I can make a point. And I can probably see that, by the way, anytime you have 2 points, you're done. Like, you can make the line and say, okay, but the problem with making 2 points is you might be really, really inaccurate when you go really far away. So maybe let's plug in a number over here, like -1 or -2, and see what happens. Let's plug in -1 and see what happens. 2 times -1 plus 3. Again, I'm plugging in -1 into this x right here, and I'm going to see what happens. So now I have 2 times -1. Whoa. I have 2 times -1 is -2. -2, and I think I need to write this out a little bit more. This is now -2 plus 3, and -2 plus 3 is 1, which means when I plug in -1, I have a height of 1. When I plug in -1, I have a height of 1. And you can see that there is now a clear pattern that this seems to be going right 1, up 1, or the reverse of that would be down 2, left 1, left 1, down 2. I could continue that pattern, left 1, down 2, left 1, down 2, left 1, down 2, and have points here, here, and here. Or I could just keep plugging in values. Again, the point of this activity is to show you all you need to know is how to use a table, and it doesn't matter if you know all the different shortcuts I'm showing you. Go ahead and plug in another one. Plug in -2. If I plug in -2, I'm going to have 2 times -2 plus 3. Again, I'm just rewriting this equation, but instead of having an x here, I'm plugging in the -2. And then I can say, okay, 2 times -2 is -4, so this is going to be -4 plus 3. -4 plus 3 is -1, which means if I have an input of -2, if I have this x coordinate of -2, what's my height? My height is actually down here at -1. So I can graph down here a -1. Oh, -1, that was a little bit off, wasn't it? -1 right here. And then, again, you can connect these with the line. You can say, okay, these should be going as a straight line, like so. And it goes on and on forever in this direction and in this direction. The more points that you graph, the better. You can see that technically I did not graph this point here or this point here, but it does match the pattern. Why does it do that? I haven't figured out why that mistake happens. So you can use a table, and I wanted to show you again, it might be a little bit tedious, but you can use a table even if you have something disgusting like this. This is a different type of form, by the way. You'll notice that I'm purposely not writing the y yet, because again, I don't know what happens. So let's go ahead and write. I don't know what happens if I plug in a 0 here. Let's see, right? Let's do this in a different color. So let me erase these blue ones. So what happens if I do I'm just plugging in 0. If I plug in a 0, I'm going to rewrite this exact equation. So the old equation was 2 times x, which is now 0. Again, what I'm saying here is x has turned into a 0. This 0 is being plugged in for this x. I'm rewriting this entire equation, but instead of writing this x, I'm writing a 0. That means I'm going to continue writing this part down here. Here we go. So I have 2 times 0 minus 3y is equal to 6. And I actually have to do some work now, because 2 times 0 is 0, and that's essentially just like scribbling it out. And now I have this equation, negative 3y is equal to 6, which means I need to divide both sides by negative 3, divide both sides by negative 3 to get the y by itself. And now y is equal to 6 divided by negative 3, which is negative 2. So I can say that y here is equal to negative 2. It's a little bit more work, but it can be done. You can say, okay, so the x-coordinate is 0, the y-coordinate is negative 2. And I can graph this on the same graph because I want to conserve space here. So 0, comma, negative 2. So 0 means I don't go left or right. I stay right in the center. So I'm staying right here, and I go down 2, 1, 2. I can say, okay, that's a point on my graph, and I can plug in another point. I can say, let's plug in 1 and see what happens. So let's plug in 1 might not be the most fun point, but will it work? Yeah, it'll be a gross fraction. What would be a fun point to plug in? If I plug in 3 here, I'll show you what happens when you plug in 1 to show you that it can be a little bit gross, which is why I advise you with the shortcut. If I plug in 1, x has turned into a 1, which means this x has now turned into that 1. I'm going to rewrite this equation, but instead of this x, I'm plugging in a 1. This is now going to say 2 times 1 minus 3y is equal to 6. And you can say, okay, really I have a 2 over here. I have to subtract 2 on both sides. If I subtract 2 on both sides, I can say minus 2, I get negative 3y is equal to 4, and then you can divide both sides by negative 3, and you can say that here that y is equal to negative 4/3, which is kind of hard to graph, honestly, but if I plug in 1, so as I say, if I plug in 1, what's the height? The height is negative 4/3, and negative 4/3 is right about there, which is kind of hard to graph. You can see where this starts breaking down, but again, I'm just trying to show, yes, you can use a table, and it might not be the best point, which is why I do advise learning the shortcuts. So this whole first page is a review on how to graph, by the way. So if you already know how to graph, then this should feel like it's a really easy review. And then on this next page, I'm talking about the new stuff, which is nice and easy, I hope. So there's 2 things that I really hope that you know for this lesson, and they're the 2 different shortcuts. There's the slope-intercept form shortcut, and there's the standard form shortcut. For the slope-intercept form, it'll generally look like this, and you guys know this pretty well. Y equals mx plus b. An example of that would be maybe y is equal to negative 2/3 x plus 1. If you see something like this form, that's the y equals mx plus b form, which is also known as slope-intercept form. So why do we call it slope-intercept form? It's because the m here is our slope, and the b here is our y-intercept. So you can see the only 2 things I have are slope and intercept, therefore the name slope-intercept form over here. Whenever you have slope-intercept, it's the same procedure over and over again. Step number 1 is you're going to plot the y-intercept. So plot the y-intercept. The y-intercept is just whatever this number is. So if this number is 2, you graph 2 on the y-axis. Step number 2, you're going to use the slope. To find more points. And I do emphasize plural points. You can just find 1 point, 2 points to find a line, but to make sure your line is nice and accurate, have as many points as possible. As a general reminder, slope is the change in y over the change in x. Some people will say that it can be another equation. You could sometimes say that this is y2 minus y1 all over x2 minus x1. You can sometimes say that this is the rise over the run. You can say that it's a bunch of things, whatever floats your boat or sinks your sub, honestly. And then always step number 3, once you get 2 points, 2 or more points, you're going to connect the points with the line. And I do have this note also that sometimes you have negatives for your slope. Make sure that the negative is either in the top or the bottom, but do not do it in both. And I'll give you an example of that right now. So here's what am I saying? So a slope-intercept form. So I have a slope here and the intercept is right here. Again, step 1 is I'm going to plot the y-intercept. So I'm going to say, you, sir, are my y-intercept, y-intercept. So I'm going to come over here and say, okay, y-intercept, done. It's on the y-axis, this axis right here. I plot 1. That was step number 1. And then from there, I'm going to use the slope. Notice that I have a negative out front. I'm going to randomly put it on the top. I could have put it in the bottom, but I'm going to put it in the top, the numerator. So I'm going to say here that my slope in this equation is equal to a -2 over a +3, and I'm going to analyze that. -2 is the change in y, and +3 here is the change in x, which means -2 is the down 2, and this +3 is a right 3. So I can analyze that. So, and you always move from that point, that y-intercept. You don't just randomly go back to the origin. So from this point that we have, I'm going to go down 2, right 3. So I'm going to go down 2, right 1, 2, 3, and I get my next point. Down 2, right 3, and you can do that again. Down 2, right 3, and then you can do the reverse of it. What happens if I had instead said that the slope was +2 over -3? What if I put the negative in the bottom? That's still okay. This now says go up 2 and go left 3, which again we can do from any of these points. If I go from this point, I'm going to go up 2, 1, 2, and the left 3, 1, 2, 3, and I get this point again. Or I can go up 2, left 1, 2, 3, and I can get another point. Get as many points as possible, and then you're going to be as accurate as possible. So there's the slope-intercept form shortcut. It makes your life much easier if you have it memorized, because it is one of the most common things in all of Algebra 1. All right, what if you have a standard form? So standard form looks like this. This ax plus by is equal to c, where the x's and y's are on the same side. A, b, and c are just numbers in this case. So maybe it would look like this for an example. In general, it's, again, 3 steps. You're going to first find, it doesn't really matter the order, 1 and 2. Here, I'll write this. These two can be interchanged. It doesn't matter what order these happen. But usually we find the x-intercept first, and then we find the y-intercept second. So let's see if you guys remember. What's the definition of an x-intercept? It's where what is equal to 0. If you said y is equal to 0, congratulations, you're correct. You always flip-flop these. To find the x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0. So here's how you do that. And by the way, once you have those 2 points, you'll have an x-intercept point, a y-intercept point. Just connect them with a line, and you're done. Let me show you how easy this becomes. So to find the x-intercept, set y equal to 0. So to find the x-intercept, set y equal to 0. So if this number is 0, it's as if I covered it with my finger, and I have the new equation 2x is equal to 4. So I'll write this down, but I wouldn't actually write this down if I were doing this as fast as possible, because I would see this in my mind's eye and I said, oh, I know what I need to do. I need to divide both sides by 2 to get x is equal to 2, and done. You go to the x-intercept, you say x is equal to 2, done. And then next you say, okay, I'm on step number 2 now. I need to find the y-intercept. I need to find where x is equal to 0. So if this x is equal to 0, 2 times the 0 is 0. And it's as if I scribbled all of this out, and I have this new equation which says -y is equal to 4. I'll write that out just for the sake of example. I have -y is equal to 4. But in general, when I'm doing this, I can see in my head, oh, I know what I'm supposed to do. I'm supposed to divide both sides by -1, divide both sides by -1, and I get y is equal to a -4. And you can say, okay, y equal -4, that means the y-intercept down here is -4, and you have your 2 points, you connect them with the line, and you call it a day. Although, pro tip, we already know, this is going right 2, up 1, 2, 3, 4. So if it's going right 2, up 4, then I can go another right 1, 2, and then up 1, 2, 3, 4. And I can find yet another point on my graph. So connect those with the line, and we are done with our function. And the third type of function that you might encounter is if you have y or x just equal to a number. So what happens if you have like y is equal to 3 or x is equal to -1? Any of these could be any number, right? So again, I'm always coming back to this idea of just use a table and you're done. Tables are the most basic ways of doing these problems. What these are telling us is a set of instructions that says, hey, I don't care what you put in for x, but I only care that the y value is 3. So essentially what this is saying is, in your table over here, just make the y coordinates 3. I don't care. Put a 3, put a 3, put a 3, put a 3, put a 3 for all the y coordinates. You can choose anything you want for x. X, you want it to be 0? Sure. -1? Sure. Put in 100? I don't care. Yeah, put in a 2 or put in a 3. It doesn't matter. The only thing that I want to have is that the y coordinate here is equal to 3. And then if you go ahead and graph these, you'll see no matter what happens, the y coordinate here is always 3, always 3, always 3, always 3, no matter where you go, which means we end up having this horizontal line. So this one is a horizontal line, and always goes through the y-axis because this is the y-axis. So I'll do that little trick too. This is the y. That x is weird. It goes through the y-axis. That looks terrible. Let me try that again. Through the y-axis. There we go. Whatever you have x equal to -1, again, it's a set of instructions that says, hey, I don't care what you do as long as x is -1, x is -1, x is -1, x is -1, x is -1. Why? I don't care what y is. It could be 0, it could be 1, it could be 2, it could be 3, it could be -1. I don't care. Go ahead and plot all those, and the x coordinate is always going to be -1, -1, -1, -1, -1. And whenever you have that, you have a vertical line. So this one is a vertical line, and another way of saying that is it goes through the x-axis. So I don't know why that line went away there, but let me go ahead and regraph that horizontal line here. All right. So that concludes all of the review. Let's move into the new stuff. So when we're doing our lesson day, remember what the title is. It's a system. A system just means more than one. In general, we're just talking about 2 lines. So if we have 2 lines, so more than one line in this case means 2, there's only 3 different things that can happen. There's 3 possibilities. So let me draw possibility 1. This is the most common thing that happens. You'll have one line that goes in one direction. It'll maybe go like that. And then you'll have a second line that goes in another direction, maybe something like that. And there's an intersection. You say, hey, say right here, maybe in a different color. That's the answer. The answer. So in this case, we have one solution. Whenever you have one solution, this is how you'll list it. You'll say it's going to be the coordinate there was maybe 3, 4, 3, 4. And then you'd box your work like that. I just made up a number off the top of my head. But generally speaking, when you have one solution, you list the x coordinate, you list the y coordinate, and you say, hey, it's wherever those 2 things intersect, because this line represents an infinite number of possible solutions that are answers for that line. This line has answers for that line. The only time where those 2 answers are the same answer is in that intersection. Okay, what's another possibility if you have 2 lines? Well, another possibility is you have a line that goes maybe like this. And your second line also goes with the same slope, and they never, ever, ever touch. So if this happens, then these are called parallel lines. Parallel lines. Whenever you have parallel lines, that means you have no solutions, so 0 solutions. And what you'll write for your answer is no solution. And you'll box that. And there is a third possibility that often people forget about. Let's go ahead and say you have a line that goes like this. And your second line is the exact same line. It goes on top of it. So your second line is the same line. So in this case, you have the same line. Same line, which means you have infinite solutions. So infinite solutions. It's kind of fun to do this one because everything is an answer. Plug in 1, or I guess 1 would be over here. Plug in 0, plug in -1, plug in 1,000, plug in a bajillion. Everything is an answer. So you can say all real numbers for this one, or you can say, I'm curious what the answer key says. In the back it says no solution, or it doesn't have any infinite solutions. So I guess the homework doesn't do any of those, but generally the way that I do it in my class is I say all real numbers. All real numbers. And I'll box that. That's how you say your answers. All right. So finally, we can get into an example for some new stuff. So let's go ahead and solve number 1 by graphing. And by the way, there's many ways to solve these. Graphing is the maybe less accurate, but kind of more visual way of figuring these out. So I'm noticing that both of these equations are in slope-intercept form. There's a slope and then an intercept, a slope and then an intercept. So let's go ahead and graph this one in a color, this one in a different color, and see where they happen to meet. So the way that we do that is we look at the y-intercept and we graph it. I'm going to do it in red. So I'm going to put a red mark right here to let me know that that one is in red. So I'm going to go up 3. That's the y-intercept. And the slope here is kind of tricky here. The slope here is equal to 2. And the slope is usually a fraction. So the slope is really 2 over 1, which means I'm going, whoa, don't know what's going on with my handwriting. This is going to go up 2 and right 1. So from this point, I'm going to go up 2, right 1, and I can't go anymore because I'm off the graph, which means I need to go and do the reverse. This is the same thing as having a slope of -2 over -1. Notice that a negative divided by negative is still a positive, which means it's allowable. And this is now saying down 2 and left 1. So down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Do this as many times as it takes, and we have our line. All right, let's go ahead and do our second equation. So we are now saying, okay, we have a y-intercept of -2, so we're going to graph -2 in a different color. And then what's the slope in this case? The slope in this scenario is equal to -1/2. And notice I'm putting the negative in the top. I could have also said that this is a 1 over a -2. In the case where it's a negative on the top, this is going to be down 1, right 2. I could have also said this is up 1 and left 2. So let's see what I have. So if I go down 1, right 2, from this point I go down 1, right 2, 1, 2, and then I get my next point, down 1, right 2, down 1, right 2, or I could go up 1, left 2, up 1, left 2, oh, that's the same point, up 1, left 2, up 1, left 2, and then I connect those with a line. And I can see where those two lines intersect. The answer here, they have crossed at one point. So whenever I have 1 point, I say, okay, the answer is at -2, -1. So the answer is -2, -1 for my final answer, which I will then box. Let's try another one. In example 2, we're going to solve this one by graphing. Oh, I'm noticing that this one is in standard form because I have x's and y's on the same side with a number on the right. I'm going to go ahead and graph. I'm going to try to find the x-coordinate or the x-intercept by just hiding u. I now have the equation -x is equal to 6. I'm going to show my work, so I'm going to write -x is equal to 6. I'm going to divide both sides by -1, divide by -1, so I get x is equal to a -6. So I'm going to come over here, x is equal to a -6, and I have the x-coordinate. All right, y-coordinate. Well, I'll hide the x. Whoa, hide the x. If I do that, then I get this equation of positive 2y is equal to 6. So I'll write that down. Positive 2y is equal to 6. I'm going to divide both sides by 2, divide by 2, divide by 2, and y is equal to 3. So I'm coming up here, y is equal to 3, and I go ahead and make a line that goes through those 2 points. Ooh, that line is a little bit off though, isn't it? Here, let's fix that. Put u. Whoa, that's not what I meant to do. Oh, I guess I can move the graph though if I'm careful about it. Let me just do the line better. Let's see. There we go. And finally, I have x is equal to 2. Oh, okay, so x is equal to means all the x coordinates are 2. So the x coordinate of 2, x coordinate of 2, x coordinate of 2, x coordinate of 2, x coordinate of 2. Oh, that's a vertical line, which means I have a line that goes like this. Like this, those clearly intersect. intersect at that point, which is 2 comma 4. So the answer here is going to be 2 comma 4 in parentheses, and that's the answer, so I'll box my answer. All right, guys, that was a long lesson because there's lots of review on how to graph, but that does conclude lesson 6-1 for systems of linear equations, solving them by graphing. Thanks for watching.